This unit is about the equation of a straight line. The equation of a straight line can take different forms depending upon the information that we know about the line. Let's start by a specific example. Suppose we've got some points labelled by their x and y coordinates. So suppose we have a point where x is 0, y is 2, x is 1, y is 3, x is 2, y is 4, and x is 3, y is 5. Let's see what these points look like when we plot them on a graph. The first point, 0, 2, will be here. An x-coordinate of 0 and a y-coordinate of 2. The second point, 1, 3, x-coordinate of 1, y-coordinate of 3. And so on. 2, 4, that will be here. And 3, 5, that will be there. You see, we've got 4 points, and very conveniently, we can put a straight line through them. Notice that in every case, the y value is always 2 more than the x value. So if we add on 2 to 0, we get 2. If we add on 2 to 1, we get 3, and so on. The y value is always the x value plus 2. So this gives us the equation of the line. The y value is always the x value plus 2. Now, there are lots and lots of other points on this line, not just the 4 that we've plotted. But any point that we choose on the line will have this same relationship between y and x. The y value will always be its x value plus 2. So that is the equation of the line. And very often we'll label the line with the equation by writing it alongside, like that. Let's look at some more straight line graphs. Let's suppose we start with the equation y equals x. We'll draw up a table of values and plot some points. Again, let's start with some x values. Suppose the x values run from 0, 1, 2, up to 3. What will the y value be if the equation is simply y equals x? Well, in this case, it's a very simple case. The y value is always equal to the x value. So very simply, we can complete the table. The y value is always the same as the x value. Let's plot these points on the graph. X is 0, y is 0, is the point at the origin. X is 1, y is 1, will be here. And similarly, 2, 2, 3, 3 will be there and there. So we have a straight line passing through the origin. Let's ask ourselves a little bit about the gradient of this line. Remember, to find the gradient of the line, we take, say, 2 points on it. Let's suppose we take this point and this point, and we calculate the change in y divided by the change in x as we move from one point to the next. Well, as we move from here to here, y changes from 1 to 3. So the change in y is 3 minus 1. And the change in x, well, x changes from 1 to 3, so the change in x is also 3 minus 1. 3 minus 1 is 2, 3 minus 1 is 2. So the gradient of this line is 1. I'm going to write that alongside here. Let's call it M1. This is the first line of several lines I'm going to draw. And M1 is 1. The gradient is 1. I'll also write the equation of the line alongside as well. So the equation of this line is y is x. Let's put another straight line on the same graph. And this time, let's suppose we choose the equation y equals 2x. Let's see what the y-coordinates will be this time. Well, the y-coordinate is always 2 times the x-coordinate. So if the x-coordinate is 0, the y-coordinate will be 2 times 0, which is still 0. When x is 1, y will be 2 times 1, which is 2. When x is 2, y is 2 times 2, which is 4. And when x is 3, y is 2 times 3, which is 6. Let's pop these on as well. We've got 0, 0, which is the origin again. When x is 1, y is 2. That's this point here. When x is 2, y is 4. That's this point here. And when x is 3, y is 6, which is up there. And again, we have a straight line graph, and again, this line passes through the origin. Right, so let's write its equation alongside. Y is 2x. And let's just think for a minute about the gradient of this line. Let's take 2 points. Let's suppose we take this point and this point. The change in y, well, y is changing from 2 to 4, so the change in y is 4 take away 2, which is 2. The change in x, well, x changes from 1 to 2, so the change in x is just 2 minus 1, or 1. So the slope of this line is 2. Let's call that m2. It's the slope of the second line. Let's write m2 is 2. Okay, let's do one more. Suppose we have another equation, and let's suppose this time the equation is y equals 3x. So the y value is always 3 times the x value. We can put these in straight away. 3 noughts are 0, 3 ones are 3, 3 2s are 6, and 3 3s are 9. And we can plot these on the same graph. Again, 0, 0, so the graph's going to pass through the origin. 2, 3. When x is 1, y is 3. So when x is 1, y is 3 gives me this point. When x is 2, y is now 6. So I've got a point up here. And that's sufficient to draw in the straight line. And again, with a straight line passing through the origin, it's a steeper line this time, and its equation is y is 3x. So we've got 3 lines drawn now. Y is x, y is 2x, y is 3x, and all these lines pass through the origin. Let's just get the gradient of this line. Well, the gradient of this line, again, let's take 2 points on it. The change in y going from this point to this point, well, y is changing from 3 up to 6, so the change in y is 6 subtract 3, or 3. And the change in x, well, x is changing from 1 to 2. So the change in x is 2 minus 1, which is just 1. So the gradient this time is 3. So let's label that m3. Now, this is no coincidence. You'll notice that in every case, the gradient, in this case 3, is the same as the number that's multiplying the x in the equation. Same is true here. The gradient is 2, which is the number multiplying the x in the equation. And again here, y is x, the number multiplying x is 1, and the gradient is 1. Now we deduce from this a general result, that whenever we have an equation of the form y equals mx, what this represents is a straight line. It's a line which is passing through the origin, and its gradient is m. The number multiplying the x is the gradient. So that's a very important result. It's well worth remembering that. Whenever you see y is a constant m times x, it'll be a straight line, it'll be passing through the origin, and the gradient will be the number that's multiplying x. Let's have a look at some other equations of straight lines. Let's have a look at y equals 2x plus 1. Very similar to the one we had before, but now I've added on a number at the end here. Let's choose some x and some y values. When x is 0, y will be 2 times 0, which is 0, plus 1. So when x is 0, y will be 1. When x is 1, 2 ones are 2, plus 1 gives you 3. And when x is 2, 2 2s are 4, and 1 is 5. So with those 3 points, we can plot a graph. When x is 0, y is 1. That's there. When x is 1, y is 3, so we come up to here. And when x is 2, y is 5, which takes us up to there. And there's my straight line graph through those points. And I'll label it y equals 2x plus 1. Let's have another one. Suppose we have y equals 2x plus 4. Let's see what happens this time. Let's suppose we start with a negative x value. X is minus 1. What will the y value be? If x is minus 1, we'll get 2 times minus 1 is minus 2, and 4 minus 2 is 2. Let's choose x to be 0. When x is 0, we'll get 2 zeros are 0 plus 4, gives you 4. And when x is 1, we get 2 ones are 2, plus 4 is 6. Let's plot those points. So if x is minus 1, y is 2. If x is 0, y is 4. And if x is 1, y is 6, which is a point up there. That's the line, y equals 2x plus 4. And you'll notice from looking at it that the two lines that we've now drawn are parallel, and that's precisely because they've got the same gradient, the number multiplying x. Let's look at one more. Y is 2x minus 1. Again, let's have some x values and some y values. Supposing x is 0. Well, if x is 0 and y is 2x minus 1, the y value will be 2 noughts are 0, subtract 1 is minus 1. If x is 1, we'll get 2 ones are 2, subtract 1 is plus 1. And if x is 2, 2 twos are 4, minus 1 is 3. Again, we've got 3 points. That's plenty of points to put on the graph. If x is 0, y is minus 1. If x is 0, y is minus 1, gives me a point down here. If x is 1, y is 1, gives me a point here. And if x is 2, y is 3, gives me that point there. And there's the straight line, y equals 2x minus 1. And again, this third line is parallel to the previous two lines. And it's parallel because it's got the same gradient. And it's got the same gradient because in every case we've got 2x. The number multiplying x is the same. So what's different about the lines? Well, what is different is that they're all cutting the y-axis at a different point. This line is cutting the y-axis at the point where y is 4. Note that the number 4 appears in the equation. This line cuts the y-axis when y is 1. And again, 1 appears in the equation. And again, this line cuts the y-axis at minus 1. And minus 1 appears in the equation. And this gives us a general rule. If we have an equation of the form y equals mx plus c, the number that it's on its own at the end here, the c, which was the 4 or the 1 or the minus 1, tells us whereabouts on the y-axis that the graph cuts. And we call this value, either the 4 there, or the 1 there, or the minus 1 there, we call that the vertical intercept. So the value of c is the vertical intercept. So now, whenever you see an equation of the form y equals a number times x plus another number, so y equals mx plus c, that represents a straight line graph where m is the gradient of the line and c is the vertical intercept, which is the place where the graph crosses the vertical axis. Now sometimes, when we get the equation of a straight line, it doesn't always appear in the form y equals mx plus c. Let me give you an example. Let's consider this equation. 3y minus 2x equals 6. Now at first sight, that doesn't look as though it's in the form y equals mx plus c, which is our recognisable form of the equation of a straight line. But what we can do is we can do some algebraic manipulation on this to try to write it in this form. And one of the advantages of doing that is that if we can get it into this form, we can read off what the gradient and the vertical intercept are. So let's work on this. I'll start by adding 2x to both sides. To remove this minus 2x from here. So if we add 2x to both sides, we'll get 2x plus 6 on the right. And now if I divide both sides by 3, I'll get y on its own, which is what I'm looking for. Dividing 2x by 3 gives me y is 2/3 of x. And if I divide 6 by 3, I'll get 2. Now this is a much more familiar form. This is of the form y equals mx plus c, where we can read off that the gradient m is 2/3 and the vertical intercept c is 2. So be aware that sometimes an equation that you see might not at first sight look as though it's a straight line equation, but by doing some work on it, you can get it into a recognisable form. What about another example? Suppose we're given some information about a straight line graph and we want to try and find out what the equation is. So for example, suppose we're told that a straight line has gradient a fifth, and we're told also that its vertical intercept c is 1. Let's see if we can write down the equation. Well, we know that a straight line has equation y equals mx plus c. So we can substitute our known values in. M is going to be a fifth, c is going to be 1, so our equation is y equals a fifth of x plus 1. Y equals mx plus c. Now we might not always choose to leave it in that form, so let me just show you how else we might write it. There's a fraction here of a fifth, and if we multiply everything through by 5, we can remove this fraction. So let's multiply both sides by 5. We'll get 5y. The 5's will cancel when we multiply by 5 here, just to leave x. And 5 ones are 5. So this form is equivalent to this form, but just written in a different way. We could rearrange it again just by bringing everything over to the left-hand side. So we might write 5y minus x minus 5 is 0. So that is another form of the same equation. And we'll see some equations written in this form much later on. Okay, let's have a look at another example. Suppose now we're interested in trying to find the equation of a line which has a gradient of a third, and this time, instead of being given the vertical intercept, we're going to be given some information about a point through which the line passes. So suppose that we know that the line passes through the point with coordinates 1, 2. Let's see if we can figure out what the equation of the line is. Start with our general form, y equals mx plus c, and we'll put in the information that we already know. We know that the gradient m is a third, so we can pop that in here straight away. We don't know the vertical intercept. We're going to have to do a bit of work to find that. But what we do know is that the line passes through this point. What that means is that when x is 1, y has the value 2. And we can use that information in this equation. So we're going to put y is 2 in, x as 1 in, and a third times 1 is just a third, plus c. From this, we can work out what c is. So 2 is the same as 6/3, and if we take a third off both sides, we'll have 5/3 is c. So you see we can use the information about a point on the line to find the vertical intercept c. So now we know everything about this line. We know its vertical intercept, and we know its gradient. So the equation of the line is y is a third x plus 5/3. Now, I want to do that again, but I want to do it for a more general case, where we haven't got specific values for the gradient and we haven't got specific values for the point. So this time, let's suppose we've got a straight line, its gradient is m, but it passes through a point with arbitrary coordinates, x1, y1. Let's see if we can find a formula for the equation of the line. Always go back to what we know. We know already that any straight line has this equation, y is mx plus c. What do we know? Well, we're told that the gradient is m, so that bit we can leave alone. But we don't know the vertical intercept c. Let's see if we can find it. Use what we do know. We do know that the line passes through this point, so that we know that when x has the value x1, y has the value y1. So I'm going to put those values in here. So y has the value y1 when x has the value x1 plus c. Now we can rearrange this to find c. So take the mx1 off both sides. That will give me the value for c. And this value for c that we have found, which you'll realize now is made up of only the things we knew. We knew the m, we knew the x1 and y1, so in fact we know this value now. We put this value back into the general equation. So we'll have y equals mx plus c, and c now is all this. And that is the equation of a line with gradient m passing through x1, y1. We don't normally leave it in this form. We write it in a slightly different way. It's usually written like this. We subtract y1 off both sides to give us y minus y1, and that'll disappear. And we factorize the mx and the mx1 by taking out the common factor of m. We'll be left with x and minus x1. And that is an important result, because this formula gives us the equation of a line with gradient m, and which passes through a point where the x-coordinate is x1 and the y-coordinate is y1. Let's look at a specific example. Suppose we're interested in a straight line where the gradient is minus 2 and it passes through the point with coordinates minus 3, 2. We know the general form of a straight line. It's y minus y1 is m x minus x1. That's our general result. And all we need to do is pop this information into this formula. y1 is the y-coordinate of the known point, which is 2. M is the gradient, which is minus 2. X minus x1 is the x-coordinate of the known point, which is minus 3. So tidying this up, we've got y minus 2 is going to be minus 2x plus 3. And if we remove the brackets, y minus 2 is minus 2x minus 6. And finally, if we add 2 to both sides, we shall get y is minus 2x minus 4. And that's the equation of the straight line with gradient minus 2 passing through this point. And there's always a check you can apply, because we can look at the final equation we've got, and we can observe from here that the gradient is indeed minus 2. And we can also pop in an x value of minus 3 into here. Minus 2 times minus 3 is plus 6, and 6 take away 4 is 2. And that's the corresponding y value. So there's built-in checks that you can apply. Let's have a look at another slightly different example. And in this example, I'm not going to give you the gradient of the line. Instead, we're going to have 2 points on the line. So let's suppose our 2 points are minus 1, 2, and 2, 4. So we don't know the gradient, and we don't know the vertical intercept. We just know 2 points on the line, and we've got to try to determine what the equation of the line is. Now, let's see how we can do this. One thing we can do is we can calculate the gradient of the line, because we know how to calculate the gradient of the line joining 2 points. So let's do that first of all. The gradient of the line will be the difference in the y-coordinates, which is 4 minus 2, divided by the difference in the x-coordinates, which is 2 minus minus 1. 4 minus 2 is 2, and 2 minus minus 1 is 2 plus 1, which is 3. So the gradient of this line is 2/3. Now we know the gradient, and we know at least one point through which the line passes, because we know 2, so we can use the previous formula. Y minus y1 is mx minus x1. So that's the formula we'll use. Y minus y1, doesn't matter which of the 2 points we take. Let's take the point 2, 4. So the y-coordinate is 4. M we've found is 2/3. X minus the x-coordinate, which is 2. So that's our equation of the line. And if we wanted to do, we can tidy this up a little bit. Y minus 4 is 2/3 of x minus 4/3. And if we add 4 to both sides, we can write this as y is 2x over 3. And we've got minus 4/3 here already. And we're bringing over 4, we'll be adding 4. So finally we'll have 2x over 3. And 4 is the same as 12/3. 12/3 subtract 4/3 is 8/3. And that's the equation of the line. Now, I want to do that same argument when we're given 2 arbitrary points instead of 2 specific points. So suppose we have the point A, coordinates x1 and y1, and B with coordinates x2, y2. And let's see if we can figure out what the equation of the line is joining these 2 points. Now, I think in this case a graph's going to help us. Let's just have a quick sketch. So I've got a point A, coordinates x1, y1, and another point B, coordinates x2, y2. And we're interested in the equation of this line which is joining them. Suppose we pick an arbitrary point on the line, anywhere along the line at all, and let's call that point P. P is an arbitrary point, and let's suppose its coordinates are x and y, for any arbitrary x and y on the line. Now what we do know is that the gradient of AP is the same as the gradient of AB. Let me write that down. The gradient of AP is equal to the gradient of AB. Let's see what that means. Well, the gradient of AP is just the difference in the y-coordinates, which is y minus y1, over the difference in the x-coordinates, which is x minus x1. So that's the gradient of this line segment between A and P. And that's got to equal the gradient of the line segment between A and B. And what's the gradient of the line segment between A and B? Well, it's the difference of the y-coordinates, which now is y2 minus y1, divided by the difference in the x-coordinates, which is x2 minus x1. So that is a formula which will tell us the equation of a line passing through 2 arbitrary points. Now, we don't usually leave it in that form. It's normally written in a slightly different form, and it's normally written in a form so that all the y's appear on one side and all the x's appear on another side. And we can do that by dividing both sides by y2 minus y1 and multiplying both sides by x minus x1, which moves that up to here. And that's the form which is normally quoted as the equation of a line passing through 2 arbitrary points. Let's use that in an example. Suppose we have 2 points, A, which has coordinates 1 and minus 2, and B, which has coordinates minus 3 and 0. Let me write down the formula again. Y minus y1 over y2 minus y1 is x minus x1 over x2 minus x1. we'll pop everything we know into the formula and see what we get. So we want y minus y1. y1 is the first of the y values, which is minus 2. y2 minus y1 is the difference of the y values. That's 0 minus minus 2. Equals x minus x1 is the first of the x values, which is 1. And x2 minus x1 is the difference of the x values. That's minus 3 subtract 1. And just to tidy this up, on the top line here we'll get y plus 2. On the bottom line here we'll get plus 2. X minus 1 there on the right at the top, and minus 3 minus 1 is minus 4. Again, we can tidy this up a little bit more. 2 will go into minus 4 minus 2 times. And if we multiply everything through by minus 2, we'll get minus 2y minus 4 equals x minus 1. And we can write this in lots of different ways. For example, we could write this as minus 2y minus x, and we could add 1 to both sides to give minus 3 is 0. That's one way we could leave the final answer. Another way we could leave it is we could rearrange it to get y equals something. So if I do that, I'll have minus 2y equals x, and if we add 4 to both sides, we'll get plus 3 there. And if we divide everything by minus 2, we'll get minus a half x minus 3 over 2. So all of these forms are equivalent. Now that's not quite the whole story. The most general form of equation of a straight line looks like this. And earlier on in this unit we've seen some equations written in this form. Let's look at some specific cases. Suppose that a, this number here, turns out to be 0. What will that mean if a is 0? Well, if a is 0, we can rearrange this and write by equals minus c, or y is minus c over b. Now what does this mean? Remember, the a and the b and the c are just numbers, they're constants. So when a is 0, we find that this number on the right here, minus c over b, is just a constant. So what this is saying is that y is a constant. Now a line where y is constant must be a horizontal line, because y doesn't change. The value of y is always minus c over b. So if you have an equation of this form where a is 0, that represents horizontal lines. What about if b was 0? Well, putting b as 0 in here, we'll get that ax plus c is 0. And if we rearrange this, we'll get ax equals minus c. And dividing through by a, x is minus c over a. Again, a and c are constants. So this time, what this is saying is that x is a constant. Now, lines where x is a constant must look like this. They're vertical lines, because the x value doesn't change. So this general case includes both vertical lines and horizontal lines. So remember, the most general form will appear like that. Provided that b isn't 0, you can always write the equation in the more familiar form y equals mx plus c. But in the case in which b is 0, you get this specific case where you've got vertical lines.